Okay, we're now going to talk about the graphs of the other trig functions, and we're going to start with cosecant. And the first period of cosecant looks like this. If this is at 0, we have pi over 2, we have pi, we have 3 pi over 2, and then 2 pi. When we graph cosecant, we are going to have an asymptote at pi, because at pi, sine is 0, and since cosecant and sine are reciprocals, when you take the reciprocal of 0, it's going to be undefined. So we have an asymptote at pi. Same thing goes for 2 pi. So anywhere that sine is 0, cosecant is going to be undefined. When we start plotting points, it's going to look like this. And this point right here will be at 1, and this point right here will be at -1. If you notice, the domain of cosecant is everything except for any multiple of pi. That's where we're going to have our asymptotes. Our range is going to be from 1 to infinity, and from minus infinity up to -1. If you notice, there is a blank space where there are no values between -1 and 1. The period for cosecant is going to be 2 pi. It repeats every 2 pi. Now, when we start graphing our translated functions, for cosecant, our key points are going to be 0, it's going to be undefined. At pi over 2, it's going to be 1. At pi, it's going to be undefined. That's where our asymptote is. And at 3 pi over 2, it's going to be -1. And then at 2 pi, we have an asymptote again, and it's undefined. So these are going to be the key points that we use when we graph translated functions based on cosecant. For the secant function, we're going to have asymptotes wherever cosine is 0, because then when we take the reciprocal of 0, we get that it's undefined. So we're going to have asymptotes for secant at pi over 2 and 3 pi over 2. So we have an asymptote here at pi over 2, and then at 3 pi over 2. When we start plotting points, it's going to look like this. At 0, we're going to have the point 1, and then it's going to come up on the left side of my asymptote at pi over 2. It's going to go to positive infinity. Then at pi, we're going to have the point -1, and it's going to come down on each side of the asymptotes. At pi over 2 and 3 pi over 2, it's going to go to negative infinity on the inside. And then at pi over 2, it's going to be at the point 1 again, and it's going to come up and go to positive infinity. So our asymptotes are going to be at pi over 2 plus pi k. So if I take pi over 2 and I add multiples of pi, that's where I'm going to get all of my asymptotes. My domain is going to be everywhere except for where my asymptotes are. So my domain is everywhere except for pi over 2 plus pi k. My range is going to be everywhere except for that blank area between -1 and 1. So my range is going to go from positive 1 to infinity, and then negative infinity up to negative 1. And then my period is going to be 2 pi. It's going to repeat every 2 pi. Notice for cosecant and secant, there are no x-intercepts. It never touches the x-axis because there's that blank space in between negative 1 and 1. Now my key points, when I go to graph translated functions of secant, my key points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, it's going to be 1. At pi over 2 is undefined because I have an asymptote there. At pi, it's going to be at negative 1. At 3 pi over 2, it's going to be undefined because there's an asymptote. And then at 2 pi, it's back up to positive 1. Okay, now let's talk about tangent. Since tangent is sine over cosine, or you can look at it as y over x, we're going to have asymptotes wherever x is equal to 0 because that's what makes the fraction undefined, and where it jumps up or jumps down to minus or positive infinity. So when x is 0, we're going to have asymptotes for tangent. Now, tangent has a period that's pi. It repeats every pi radians. So of the 6 trig functions, 4 have a period that's 2 pi, and tangent and cotangent are the only 2 that have periods of pi. So when I graph my key points and I break pi up into 4 pieces, of those 4 pieces, we are going to have asymptotes at pi over 2. And that's it, because of those values, pi over 2 is the only one where x is 0. At pi over 4, tangent is positive 1. And at 3 pi over 4, tangent is negative 1. And tangent is 0 at 0. I'm going to come up like this and go to positive infinity on the left side of pi over 2. And then on the right side of pi over 2, I'm going to come down to negative infinity on the right side of pi over 2. And then at pi, I end up back up at 0. So this is one cycle of tangent. Now our key points that we'll use when we do translated functions of tangent are 0, pi over 4, pi over 2, 3 pi over 4, and pi. At 0, tangent is 0. At pi over 4, it's 1. At pi over 2, it's undefined because we have an asymptote there. At 3 pi over 4, it's negative 1. And then at pi, we come back up at 0 and start the cycle again. For cotangent, again, it has a period of pi. And cotangent is cosine x over sine x. So my asymptotes are going to occur whenever sine x or y is 0. So y is 0 at 0 and pi. So we're going to have asymptotes here and here. At pi over 4, cotangent is 1. And at 3 pi over 4, cotangent is negative 1. At pi over 2, cotangent is 0. It's going to come up on this side, and it's going to come down on the other. So it's going to be a decreasing function. Going left to right, it's decreasing. My key points when we graph translated function, because it has a period of pi, we're only going to go from 0 to pi, and we're breaking it up into 4 pieces. So at 0, it's undefined because we have an asymptote there. At pi over 4, it's 1. At pi over 2, it's 0. At 3 pi over 4, it's -1. And then at pi, it's undefined because we have an asymptote there. For both tangent and cotangent, my range is -infinity to infinity. There's no breaks in the graph vertically. I obtain all the y values. But for the domain is going to be all the places except for where we have asymptotes. So for the domain for tangent, it's going to be all values of x except for pi over 2 plus a multiple of pi. And the domain for cotangent, except for multiples of pi. Now let's go ahead and go through and do the same thing that we did in the previous section with the other trig functions. We're going to graph all these translated functions. So for cosecant, we have this general function where A tells us about any vertical stretches that we have. B helps us figure out our new period. C is going to help us determine any horizontal shifting, and D is going to determine any vertical shifting. To find the new period of this translated function, we're going to take the original period of cosecant and divide by B. Since cosecant has a period of 2 pi, and we divide by B, notice what's in front of the x is 1, so my period is going to be the same. 2 pi divided by 1 is 2 pi. So the length of my first cycle for this translated function is going to be the same. Phase shift is going to be pi over 4, that's my value of C, and because it's a minus pi over 4 in the equation, that means it's going to go right pi over 4. So instead of starting at 0, we're going to shift it over to the right and start at pi over 4. I'm going to wait to go over the asymptotes here in just a minute. And the scale is going to be 2 pi divided by 4. Right, it's the period divided by 4, so we break it up into our 4 chunks, which is going to be pi over 2. So we're going to start, because it's shifted over pi over 4, we're going to start at pi over 4, and I'm going to keep adding a half a pi. So if I take pi over 4, and I add pi over 2, that's going to give me 3 pi over 4. Then if I add pi over 2 again, that's going to give me 5 pi over 4. And then if I add pi over 2 again, that's going to give me 7 pi over 4. And then it'll be 9 pi over 4. You can check to make sure that you still have a period of 2 pi by taking 9 pi over 4 and subtract pi over 4. That's going to give me 8 pi over 4, which is 2 pi. So it works. My length of my period or my cycle is still the same. Okay, now that we have our table made out and we can see where it's undefined, that's where our asymptotes are. So I'm going to go back up to where it says what are the asymptotes, and I'm going to put down that at x equals pi over 4, at 5 pi over 4, and at 9 pi over 4. That's where we have our asymptotes for this function. Now, if we go back up and look at our key points for cosecant, we're going to start where it's undefined, then we're going to go to 1, then undefined, then -1, and undefined. Since there's no vertical stretching and no vertical shifts, we don't have to worry about changing those values. Okay, now let's go ahead and graph this. So here's 1, here's -1, and we're doing this on a scale of, let's see, we said pi over 2. So I have pi over 2, then pi, then 3 pi over 2, then 2 pi. Pi over 4 is going to be halfway between 0 and pi over 2. And that's where we're going to have our asymptote. That's where it's undefined. We're also going to have an asymptote at pi over 4. Pi over 4 is between pi and 3 pi over 2. So I'm going to have an asymptote here as well. And then at 9 pi over 4, we also have an asymptote there as well, which is right after 2 pi. And then at 3 pi over 4, which is between pi over 2 and pi, we go to 1. And then at 7 pi over 4, which is between 3 pi over 2 and 2 pi, we go to -1. And so here is the first cycle of cosecant x minus pi over 4. Now let me show you how you can check this on your calculator. Okay, to check this on your calculator, since we don't have a cosecant button on our calculator, we have to use the fact that cosecant and sine are reciprocals. So if I graph cosecant of x minus pi over 4, that's going to be the same thing as graphing 1 divided by sine of x minus pi divided by 4, because cosecant and sine are reciprocals. So now let's go to the window and set our window. Since we're starting at pi over 4, because it's been shifted to the right, pi over 4, my x-min is going to be pi divided by 4. Our x-max is going to go out to 9 pi over 4. And we did this on a scale of pi over 2. Now we're going to leave x-min and x-max at -10 and 10. Since we are going to positive and negative infinity, we want to at least see out more than, a couple units. So we'll just leave that at -10 and 10. Now when I hit graph, we should see what we just graphed by hand, the full cycle of cosecant. The first full cycle of cosecant x minus pi over 4. Okay, so now for the next example, we are going to graph 1/2 secant x minus pi over 6. Now the general formula is A secant b times x minus c plus d, where A tells us what the vertical stretches are, B helps us find the new period of the translated function, C tells us about our horizontal shift, and D tells us about our vertical shifting. So, if you notice, the coefficient of x is 1. So I'm going to take my original period for secant and divide by my value of b to find the new period. The original period is 2 pi, and my value of b in this case is 1. So the length of my period for the translated function is still going to be 2 pi. My phase shift here is going to be pi over 6. Because there's a negative in front of the pi over 6, that means I'm going to move it to the right, pi over 6. We're going to wait after we set up our table to find the asymptotes, and then the scale is going to be our period divided by 4, so we can split it up into our 4 chunks. So my scale is going to be pi over 2. So I'm going to start at pi over 6, and I'm going to keep adding pi over 2. So when I take pi over 6 and I add pi over 2, that's going to give me 4 pi over 6, which is 2 pi over 3. Then when I add pi over 2 again, I'm going to get 7 pi over 6. When I add pi over 2 again, that's going to give me 5 pi over 3. And when I add pi over 2 again, for my ending point, it's going to be 13 pi over 6. I can check to make sure the length of my period is correct. I should have a length of 2 pi. So if I take 13 pi over 6 and I subtract pi over 6, I might take my ending point and subtract my starting point. That's going to give me 12 pi over 6, which is 2 pi. So it works. Now, if we look at the graph of secant, so we start at 1, and since we have a vertical compression, I'm going to cut it in half. Normally we start at 1, but now we're cutting it in half, so this is going to be 1/2. Then the next point will be our asymptote, which would be undefined. Then my next point would be at -1, but since we're cutting it in half, that's going to be -1/2. Then my next point would be where it's undefined. Normally, the last point of the cycle for secant stops at 1, but because we have a vertical compression by 2 and everything's getting cut in half, that is now going to be 1/2. Now that we see on our table where our asymptotes are, I can label them here. Our asymptotes are at x equals 2 pi over 3 and 5 pi over 3. So let's go ahead and plot these points. So here's 1/2, here's 1, here's -1/2, and here's 1. We are starting at pi over 6, but we're doing this on a scale of pi over 2. So I'm going to start off at pi over 2 pi, then 3 pi over 2, then 2 pi, then 5 pi over 2. So pi over 6 is about 1/3 of pi over 2, so that'll go about right here. And I'm going to come up to 1/2. So this is at pi over 6. Then at 2 pi over 3, that's about right here. That's where it's going to be undefined. And then at 7 pi over 6, which is a little bit past pi, that's going to be at -1/2, so about right here. And then at pi over 3, which is a little bit past 3 pi over 2, that's going to be my other asymptote. And then at 13 pi over 6, which is a little bit past 2 pi, I'm going to come back up to 1/2. And when I graph that, it's going to look like this. Okay, now let me show you how you can check this on your calculator. Okay, we are going to go in and clear out what we have in there so far. And we're going to put in our new equation. And our new equation is with the function secant. We don't have a secant button on our calculator, but we do know that secant and cosine are reciprocals. So if I want to graph 1/2 secant of x minus pi over 6, that's going to be 1/2 and then 1 times 1 divided by cosine of x minus pi over 6. Now let's go to the window and set it up. We're going to start our cycle at pi over 6. So that's our x min. We stop our cycle at 13 pi over 6. And we're doing this on a scale of pi over 2. And since we have asymptotes here and we want to see far enough up and down, I'm just going to leave it as -10 to 10. And I'm going to hit graph, and we should see what we had graphed by hand, that first cycle. Okay, the next example is with cotangent. Our general formula for cotangent will look like this. A is our vertical stretch or shrink. B will help us find our new period. C tells us our horizontal shifting, and D tells us our vertical shifting. So this one does have a coefficient in front of x other than 1. So I'm going to have to factor that out. I'm going to pull out and factor out that pi. I'm going to factor out that pi, so I get pi x minus, and that's going to give me a 1/3 when I divide pi over 3 by pi. So my new period is going to be the old period, the original period divided by b. Now cotangent is one of the two functions that has a period of pi. That's my original function for my original period for cotangent. Then I'm going to divide by pi, which is my value b, so my period is going to have a length of 1. My phase shift is 1/3, and because it's -1/3 in the formula, that means I'm going to move it 1/3 to the right. Asymptotes, we're going to hold off on that until we get it from our table. And then the scale is, I'm going to take my new period and divide by 4 to get a scale of 1/4. So I'm starting at 1/3 because I shifted. I usually start at 0, but I'm shifting everything over to the right 1/3. And I'm going to do this on a scale of 1/4, so I'm going to keep adding 1/4. So if I take 1/3 and I add 1/4, that's going to give me 7/12. And then if I add 1/4 again, that's going to give me 5/6. And then if I add 1/4 again, that's going to give me 13/12. And then if I add 1/4 one more time for my last point, that's going to give me 4/3. Now I can check to make sure that my length is correct. I should have a total period of 1. So if I take 4/3 minus 1/3, that definitely gives me 1, and it works. Now when I look at the mother function for cotangent, cotangent is going to have asymptotes wherever y is 0. So that's going to be here at the beginning and at the end. And the center point is going to be at 0. And then the second point is going to be up here, and the third point is going to be down here, and it's going to look like this. So normally this would be at 1, and normally this would be at -1. So at 1/3, we're going to start with an asymptote. Then the next point would be at 1. Since there's no vertical shift and there's no vertical stretching, I can just leave it at 1. 5/6 is our center point, so that's going to be at 0. And then our next point would be at -1. And then our last point is going to be where we have our asymptote, which is undefined. So let's go ahead and graph this. Since we are doing this on a scale of 1/4, I'm going to make every 2 1/4. Okay, 1/3 is going to be a little bit bigger than 1/4. So my asymptote is going to be about right here. And then I also have an asymptote at 4/3, which is a little bit bigger than 5/4, which looks like this. Then at 1, and then at 7/12, which is a little bit bigger than a half, it's going to come up to 1. And then at 5/6, which is a little bit bigger than 3/4, that's going to come about right here. Then 13/12, which is a little bit bigger than 1, is going to come down to -1, about right here. And so this is going to be our graph of the translated function for cotangent. So now let's check this on our calculator. I'm going to go into y equals and clear it out. Now, we do not have a cotangent button on our calculator, but we know that cotangent and tangent are reciprocals. So if I want to graph cotangent of pi x minus pi over 3, I'm going to do 1 divided by tangent of pi x minus pi divided by 3. Now go to the window, and we are going to set our window. Our x min, where we start our first cycle, is going to be 1/3. We are going to finish our cycle at 4/3. And we're doing this on a scale of 1/4. And to make sure that we see our asymptotes, we're going to just leave it at -10 to 10 for our y-axes. And if we did it correctly, when we graph it, we should see our first full cycle of what we just graphed by hand. So the last example is tangent 2x minus pi over 2. So our general formula looks like this. Since we have a coefficient in front of x that's not 1, we're going to have to factor out that 2. So then we can identify our b and c. So our period for the new translated function is going to be the original period divided by my value of b. Since tangent is one of the two functions that has a period of pi, we're going to take pi and divide by 2. So the length of our period is going to be pi over 2. Our phase shift is pi over 4. And because it's x minus pi over 4, that tells me it's going to shift right pi over 4. So instead of starting at 0, we're going to bump it over and start it at pi over 4. We're going to hold off on finding our asymptotes until we fill out our table. And the scale is going to be our new period from the translated function divided by 4, so we can split it up into our 4 chunks. So our new period is pi over 2, and when I divide that by 4, I'm going to scale this by pi over 8. So we're going to start at pi over 4, and we're going to keep adding pi over 8 to get our key points. So if I add pi over 8 to pi over 4, that's going to give me 3 pi over 8. Then if I add pi over 8 again, that's going to give me pi over 2. Then if I add pi over 8 again, that's going to give me 5 pi over 8. And then one more time would give me 3 pi over 4. Now if we look at our mother function for tangent, unless it's shifted or something, tangent starts at 0, 0. Then it comes up to 1 for the second key point. Then we have an asymptote. And then it comes down to -1. and then back up to 0 to start over. So it will look like this. So our key points are going to split it up into its 4 chunks. There's 1, 2, 3, and 4. So if we look at the first point, since it's not shifted or vertically stretched, our value is still going to start at 0. Our second key point is going to be at 1. Then our next key point is going to be an asymptote, so that's going to be undefined. And then our fourth point is going to be at -1. And then we're going to end at 0 so it can start the cycle again. Okay, so now we have our table filled out. So we can identify that our asymptote is at pi/2. So let's go ahead and graph this now. So I'm going to come out. Here's 1. Here's -1. Since we're scaling this on pi/8, I'm going to keep adding pi/8. Okay, so we have our asymptote at pi/2. We have 0 at pi/4 and 0 at 3 pi/4. And then at 3 pi/8 it comes up to 1. And at 5 pi/8 it comes down to -1. So here's our translated graph, our picture. And so now let's take a look at it on the calculator to make sure that we did this correctly. Okay, so let's put in our y equals. We'll put our equation in our y equals. And we do have a tangent button on our calculator, so I can just hit the tangent button and not have to worry about doing reciprocals. And this is going to be 2x minus pi/2. And then close parentheses. Okay, let's go to the window. Okay, we're going to start at pi/4. That's the beginning of our period. So I'm going to put in pi divided by 4. Then the last value of our period is 3 pi/4. We're going to do this on a scale of pi/8. And since we have an asymptote here, I'm going to leave it at -10 to 10 so that we can go out far enough to see what happens. Okay, now I'm going to hit graph. And if we did this correctly, we should see exactly what we just graphed by hand on our calculator. And it looks good.